Because I've been there and I didn't get A's. That's just a fact. I just didn't get A's. Couldn't. There just wasn't enough time. But I did manage to get B minuses. So you can do that. Okay, so I would like to go over some of what's going to be on the quiz so that you have a good understanding. And this is based off, thank you for starting the homework early, because now I have questions coming back at me early and I can address them here. I wanted to give you a different example of a diagnostic test. This is breast cancer. So when people come into a physician's clinic, they should be weighed. We've recommended it in several journal articles. Please weigh your patients. But if they weigh at a high level, then we would want to tell them you're at risk for, is that bad or not? You're at risk for something. In this case, you have the body mass index. We've talked about that several times in here now. The body mass index is your weight divided by your height squared. Just want to remind you to put your cell phones away. I just forgot. I put mine away too. I hope it's not on. I hope it's on silent. So the body mass index is weight divided by height squared in kilograms per meter squared. And so what that does is it mods out the height. And I think we talked about this. You know, we probably were the same weight at one time, unfortunately for me. But, you know, if we were the same weight, he's taller than me. His height is a factor. So if I told you I got two people in from the class and they're both, I was 179 pounds at my maximum, they're both 179 pounds. You have an image in your head of what you're looking at. Now I say, well, one of them is 6'2", and the other one's 5'4". Now you have a different image in your mind. And probably you would go to the 5'4" person and say, you have to lose some weight. Right? That's exactly what my doctor told me. Got to lose some weight. So that's why we mod by height squared. We divide by height squared, so we even everybody out and normalize them. So this is an index that we have of adiposity. Over here, what you have is data from patients. These are patients with breast cancer. So there's 300 total patients. 200 of them didn't have breast cancer, and 100 of them did. And in each setting, you're saying, well, what if I have a patient who comes into the doctor's office and has a BMI of 18? Is that a diagnostic for having breast cancer or not? So true positives are the number of people that you correctly diagnosed as having breast cancer. They're truly positively identified as having breast cancer. That's how I think of it. False positives are the ones that you falsely told have breast cancer when they really don't. You falsely told them they were positive for the disease and they're not. That's how you should think of that. So on the homework, I asked you that. What is a false positive? What's a true positive? I've asked you those questions. On the quiz, I will also ask you those questions. So a patient walks in the office and you find out they're false positive. Their test came out a false positive. What does that mean? True negatives. Those are people who don't have the disease that you correctly flagged as not having the disease. So you truly told them you don't have the disease. And I think I did a false negative. You falsely told them they didn't have the disease when they really did. That's what those numbers are. So the data is given out here a little bit different than what you saw in the first set of data, but still the same kind of data. So I wrote it down here. False positive means that 200 patients didn't have the disease, but they were classified as they were falsely classified as positive for the disease. Got it? Okay, what I would like you to do is to calculate the sensitivity and specificity for each one of those cut points. The sensitivity and specificity are your rate of diagnosis. How good of a grade are you getting at diagnosing people correctly? There's two aspects to this. One is you want to accurately tell people they have breast cancer when they really have breast cancer. But we talked about another thing that you want to be accurate at on Monday's class. Do you remember what it was? You don't want to be just good at telling people they have the disease when they really have it. What else do you want to be good at? I'm going to give it a shot. That's right. Right. You don't want to tell someone they have cancer when they don't have cancer. That's bad. That can you imagine that? That would be terrible. That would be devastating. So you want to be good at both. So right here at BMI equals 18, I do one calculation for you. Take the notes down because the previous class, they used this. They kept asking me to go back and forth on the slides. So what you want to do is take the total that you got right, positively identified as having the disease, divided by the total that were actually diseased. So this is your rate of getting it right for accurately defining how the person that got the disease, the You know, you have it. I accurately told you you have it. And I got BMI equals 18. 100 people were classified as having breast cancer, and 100 people had breast cancer. I got it right 100% of the time. Does that make sense?
I'm sorry, so how do you
It's the true positives. These are the guys that you correctly identified with your cut point as having the disease, divided by the actual amount that were correct. It's the percentage you got right in diagnosing them correctly having the disease. Right? So 100 people had breast cancer. Right? That's down. You got them all. All 100 of them were flagged as having breast cancer. The true positives divided by the total amount of disease, right? So it's your percentage that you got correct in your identification. So BMI is 18. I don't think any of us, maybe you have a BMI of 18. Do you know your BMI? It's a really small BMI. You probably don't. 18 is underweight. And we had a guy, I think, in our night class once that had a BMI below 18. He was a stick. He was a stick. So BMI being 18 is really, really small.
It's weight divided by height squared.
Weight divided by height squared. So you're looking at someone who's really. Change it to meters, and you take. I'll give you transformations. I'll get your BMI transformations.
Right.
So this is really, really small here, right? So you're saying if that's underweight, most of our country is not underweight. That's everybody, right? If you make your BMI cut point 18. And you tell everybody with a BMI of over 18, you've got breast cancer. You're telling everyone they have breast cancer. So of course you got everybody right, because all the people that had breast cancer walked into your office, and all the people who didn't have breast cancer walked in your office, and you just told them all, you all have breast cancer. So you positively identified all 100 people that had breast cancer. So that makes sense, right? So when I get numbers like this, when I do an application, I always go, does that make sense? Especially when I get weird numbers like 1. So what do you think? Does that make sense?
I think so.
Okay, so at 18, you told everybody with a cut point of 18 and above, you told them all, you have breast cancer. And because everybody is above 18, you just told everybody they have breast cancer. So what's that going to do? What do you think that's going to do if you just tell everybody they have breast cancer? All of you have breast cancer. That means anybody who does have breast cancer, I correctly diagnosed you. What's the problem with that? That's not accurate because all those people who don't have breast cancer, it just scared them. Scared them. So that's the problem. If you want to get the absent one, the one that don't have the disease correctly, how many of those did you get right here? Those would be the true negatives, the ones that you correctly identified as not having breast cancer. That's none. Right, I've got none of those right. And there's 200 of them that don't have breast cancer, so I got a big fat F minus on my ability to catch the people who don't really have the disease. So is 18 a good cut point for telling people they have breast cancer? Probably not, right? Because not that you wouldn't catch everybody, that you'd probably be telling everybody to get help. But what the issue is that you told a whole bunch of people who don't have breast cancer that they did. That's the problem.
So anyways, you could use both true positives and false. The true negatives and
you need to evaluate both. Is that what you're asking? You have to do both, right? It's a balance. It's a balance between both. And they were just asking me that over the phone. I've got a couple of researchers writing a paper right now on children. And I told them, you can't just report one. You have to report both. It's a balance between both. You've got to get this the true positives correct, and you also have to get the true negatives correct. And you might not get that perfect, but you want them both as high as they both can be simultaneous. You're optimizing both of them at the same time. Can you put your computer away? Yes. Thank you. Okay, so I have the first sensitivity and specificity here. I'd like you to fill out the rest of this table. It's a little bit of number crunching, but I'd like you to see, it didn't take them that long, 5 minutes it took them this morning. So take a little bit of time here and fill this out with your partners and match up the numbers. It's just number crunching, but I want you to get a feel for how the numbers change as you go down the stack. What do you think will happen? Just out of curiosity, what do you think will happen? Because as you're going down here, the people are getting heavier and heavier. So what do you think will happen at some point as you go down the cut points with these sensitivity and specificity numbers?
The higher the BMI, the more true positive it is, and the more sensitivity.
Right, these numbers should get higher,
Yeah.
right? And eventually, you're gonna get really, really high, that your net is not cast wide enough, and you're going to be large on this number. You're gonna tell people they don't have the disease when they really don't, but you'll actually mess up this number, right? Because your net was tested. If you take BMI is 40, that's really, there's no one in here that has a BMI of 40. Okay, so if somebody has a BMI of 40 and you're using that as your cut point, then somebody has a BMI of 34 is also heavy and you can cut them in the net. So you need to catch both.
Just to make sure that I'm doing it correctly. So say for BMI of 20, right? For the specificity, it would be.
I'm gonna go back to those slides so you can
True
look them up.
negative
Okay, right?
divided by false negative, false positive.
No, true negative
Divided by false positive.
specificity is all the ones who are absent from the disease that you flagged divided by all of them who truly don't have the disease. So
So true negative divided by false positive.
true negative divided by the total number disease free.